Hi, and welcome back to Subtractive Synthesis 101 with Sonic Academy. In this video, we're going to have a look at the architecture of a subtractive synth, or in other words, the signal flow. I've made four examples, four diagrams, just giving very simple idea and a very simple layout of how you could kind of connect a subtractive synth together. So let's move over to diagram 1, if the computer will let me. There you go. Right, what you can see here is on the left you'll have an input section, which would be something like your MIDI controller keyboard or a sequencer feeding a signal to your synth. Now that signal would usually comprise of things like the note on, note off, so the note length, where it starts, where it finishes, and also things like pitch, so telling the synth what notes to play. The first component of the synth in the chain is the oscillator. This is your starting point or your building block. And your input section will tell the oscillator when to switch on and when to switch off, and which notes to play, as I just mentioned. Once the signals come out of the oscillator, it then feeds into a filter, usually. What the filter will do, you can use something like a high-pass filter or a low-pass filter or a band-pass filter. And this is going to shape or sculpt the sound in some way. That signal then passes on to the amplifier, and all the amplifier is it means volume, how loud the signal is going to be. And then it's passed on to the output, so your output will be your sound card, which then feeds the signal to headphones or your speakers or something. And if you look underneath, we've got a section called modulator. Modulation's something which we're going to take a far more in-depth look at later on. But modulation just means change over time, and the best way to think about modulation is a mini version of automation within the synth. So if you're using a DAW like Ableton Live or Logic or Cubase at the moment, you're probably very familiar with automation already. So you think about modulation as automation within the synth, and it makes it a lot easier to kind of imagine. Right, let's look at another example here, which is slightly more complicated. Now here we've got the same kind of setup, but in this instance we've got two oscillators and two filters. So what you'll have, if you've got two oscillators or more, they will then feed into a mixer. And what that usually means is on each oscillator section you've got a volume control, although some synths like the Minimoog do have a mixer section visible. That then moves on to your filter, as in the previous example. That's where you do your initial sound shaping. But then the difference is it moves on to another filter. And what we call this setup is two filters in series, which means one after the other. So your signal passes into one filter, the sound is shaped by that first filter, and then that finished shaped sound is moved on to the next filter, where you can do some more shaping. And then it goes on to the amplifier and the output like it does before. In the third example here, we've got the same oscillator setup, but the filters are now set up in parallel. And what this means is instead of being the signal coming from the oscillators through the mixer and being passed from one filter to another, the signals pass to both filters at the same time, and you can hear the changes happening at the same time. This is quite important because it completely alters the way that the filters work. Even if you're using two filters still, it sounds very different. But we'll look into that a bit more later on when we do some sound design examples. You can hear what the difference is between series and parallel. And in the last example, I've got exactly the same basic setup, but now I've given a couple of examples of modulation as well. Now you don't need to worry too much about what the modulation is doing at this point or how it's going to sound, but it just shows you where it can feed into the signal path, because most of the synths are going to give you something called a modulation matrix, big words, and the modulation matrix allows you to route synths from one part of the synth to the other. So for example here we've got LFOs, or low frequency oscillators, affecting both oscillators. Now in the modulation matrix you might have LFO on oscillator 1 affecting the pitch of oscillator 1, and on oscillator 2 it could be doing something like altering the pan from left to right. And another type of common modulation that you've got is an ADSR, or attack, decay, sustain, release envelope. And again, that's just another kind of automation. And on this example, an ADSR envelope could be adjusting the cutoff value of filter 1, and it could also be adjusting the volume of the amplifier. And then there's another LFO on filter 2 which could be doing something else like adjusting the resonance backwards and forwards. So now you've got a very, very basic idea of how the signal's routed through a synth. In the next video we're going to start looking at the components, and we'll start off with the oscillators. I will see you there.